Hi everyone, welcome to this module. Here we'll have a look at rooftop mounting structures for solar systems. So there are lots of different mounting systems for lots of different types of roofs. And solar mounting system is an important part of the system that also requires proper planning and installation. There's ongoing innovation in this area to make installations as quick and as cost effective as possible. In this module, we'll have a look mainly at rooftop mounting systems and not at ground mount systems. Great, so some topics that we will cover in this module is how the different systems is fastened to the roof, how to ensure proper access to the modules for cleaning and maintenance, walkway constructions to protect the roof from damage. And we've divided the mounting systems into 4 different categories: penetrating, non-penetrating, roof or facade, integrated mounting systems, and then finally we'll have a look at some challenging roofs. Okay, so the first type of roof we'll have a look at is a corrugated iron roof with wooden beams underneath. Here, one of the options is to use a hanger bolt, also called anchor bolts. The anchor bolts screw through the roof metal into the wooden beams underneath. And these wooden beams can also be called purlins or roof rafters. The anchor bolts has a rubber seal that seals against the metal roof and protects it from any water penetration. And then a metal plate is held in place with 2 nuts, and the rails is then mounted on top of these metal plates. This is a very strong and sturdy way of mounting solar panels on metal roofs. The hanger bolt system works well for both corrugated iron and trapezoidal roof sheets, also called IBR sheets. So the sheet here at the bottom is called IBR, and this is corrugated iron. And it's also adds strength to the metal roof, as the metal sheets are fastened on more places than before. So it's not necessary to remove the existing screws, as the hanger bolts will just be installed in between the existing screws where there's no screws yet. And it should always be installed on the high part of the wave or the IBR curve as well, to ensure the roof stays waterproof. Another method of installation on metal roofs is to attach the mounting system just to the metal sheet itself. This is obviously not as strong as a hanger bolt, but as the modules are mounted directly parallel with the metal sheet, there's not a lot of pressure on the panel's mounting system from wind and other forces. Also, the advantage of this mounting system is that it's quicker to install and cheaper than the hanger bolts and rails. So here are some examples of what the installation can look like. On IBR roofs, this is also called a short rail system, where the short rail is mounted with either self-drilling screws on the high part of the IBR roof or with pop rivets. With this systems, the panels are mounted directly on the short rail, thus eliminating the long rails and that attaches to hanger bolts. And leads to a lot of cost savings. Here you can see the short rails mounted on the roof, and then the panels mounted on top of these short rails. A very cheap, cost-effective mounting system. Here on the left you'll see what it can look like on corrugated iron, with the mounting system just attached to the sheet itself. Just some other examples as well, options that can be used. The challenging thing about systems like this is that if the profile or shape of the roof sheet changes and it's not the same, it could lead that the system not fitting properly and not being compatible. If you get different heights and widths of the IBR roofs. Now we come to a special roof, the slate roof. It is a very difficult roof type that needs a lot of high quality work and material, so be careful if you take on clients with these types of roofs. Slate roofs are difficult to work with tiles breaking and causing leaks. One would be better off finding and appointing a specialist in slate roofs rather than trying to do it oneself. A leaking roof will always be blamed on the solar contractor. Also, this mounting system on this type of roof might not be as strong or as durable as expected, especially if you get some movement from wind. Let's have a look now at a flat roof and a penetrating mounting system. There are many different options for this type of roof, and here is one of them. The bolts can be secured to the roof either by a chemical anchor or mechanically. So holes are drilled into the roof and then filled by chemical material that anchors it there, or a mechanical something that expands and keeps it secure in the roof. So you can see here the rows of panels fastened to the roof with those bolts, and that will prevent it from blowing away if there's any strong winds. The problem with this is that if it's not properly installed and sealed, it might cause roof leaks. So a lower risk option might be an east-west option for flat roofs. The next roof type we'll have a look at is called a raised seam roof or clip block roof. These roofs consist of metal roof sheets with raised seams that can fit over each other and that is attached to the roof with on these raised seams. These sheets can be installed either at a steep angle or virtually flat. It is probably the easiest, quickest roof type to install solar power on. Here the mounting clamps are just clamped on top of these seams, and there's no need for any roof penetration that could cause possibly water leaks. So a very quick and easy way to install solar power on a roof. Okay, this is a very common mounting system, and it's used quite often, as most homes has tile roofs. The roof hook is attached to the rafter underneath the tile, and it's a very strong solution as the rafter is very strong mostly. And then to hold the roof hook in place, one uses two large wood screws. Okay, so here's the overview of how it's installed. So the first step is to remove the tile. That can be quite difficult, and one needs to lift out the other tiles before one is able to lift out one tile, the surrounding tiles. And then one needs to place the roof hook on the rafter and make sure that the spacing is correct between the tile and the roof hook, the tile underneath and the roof hook. And you might need to use spacers, and it's important to ensure that there's no pressure on this tile, as that can cause the tile to break when you fasten this screws, either now or at some point in future, and then you have a callback to come and fix the roof. And then two long large wood screws are used and fastened to the roof rafter, and then the tile that was removed, a piece of the tile is cut out with a grinder underneath in order to make space for the roof hook to come out. It's important to ensure that the tile fits snugly again, and that all tiles are put back correctly, as if not, that can cause roof leaks, and that's quite easy to happen if you don't ensure that the tiles are all placed properly. Here are examples for flat roofs again, which are alternatives if you are not allowed to drill into the roof. These options work very well. On the left hand side, you've got a black plastic tub that's ballasted down with stones. I found these to be a bit of an expensive solution, but it works quite well and easily. One just needs to ensure that it's ballasted down properly with enough weight. And here on the right, these metal bricks are used, and then the mounting system is fastened on top of those. The only thing with these ballasted system is that one needs to ensure that the roof can handle the extra weight, and the engineer needs to certify that it is all okay. Great. So another option for flat roofs is to use the east-west installation for solar panels. This is a very popular solution for several reasons. Firstly, no extra weight on the roof is required to ballast down the panels. There's a very low resistance against wind and danger from wind damage, as east-west mounted solar panel doesn't offer a lot of resistance to wind. And also the solar production curve for east-west installation often matches the consumption much better than a pure north or south facing installation. So one can consume much more of the solar energy in the building directly, instead of exporting to the grid or having to save it into the battery for later consumption. Here you can see what an east-west installation will look like from the side. And different manufacturers got different solutions. So typically inclination here is 10 degrees for the solar panels. So if we have a look at a few challenging roofs, thatched roofs, which is quite popular in South Africa. Unfortunately, it is not recommended to install solar panels on thatched roofs for various reasons. Fire danger, the roof, the grass rotting underneath, and it just doesn't look good. One would rather find alternatives, build a carport or something, and not install on thatch. Another challenging roof type is asbestos roofs. These roofs are quite common in a few African countries like Zambia. It has the same shape as corrugated iron roofs, but just with larger waves. A similar looking roof is fiber cement roof sheeting. It looks very similar to asbestos, but contains no asbestos and is made of fiber and cement. The problem with asbestos is the health concern, especially if it's rolled and there is some dust that you can breathe in. A lot of countries have outlaws and banned these roofs and programs to replace them, but in reality it's not always done. Another challenge is that asbestos gets brittle over time. So this gets dangerous to install on, especially if one can potentially fall through the roof. And it can also crack and cause water leaks. So here on the right you can see a mounting system that's designed specifically for this roof type, where the roof penetration is here on the high part and it's just got 2 feet standing on the valleys. And then your mounting rails are just installed on these brackets. One important thing to keep in mind when planning and installing a solar system is access to the solar panels. Here you can see 2 examples with no to very little access to the solar panels. This can lead to problems in the long run. For operation and maintenance reasons, it is important that one can easily get to every panel from walkways or spaces left between the rows and columns of panels. This is so that one are able to clean the panels or test or replace if necessary. Here you can see a better installation with walkways for O&M, operation and maintenance. The example on the right, the spacing between the modules were made bigger. This was done to decrease the total weight on the roof. Normally 30 centimeters is wide enough for walkways. Here is a very impressive example of a large 3 megawatt peak solar system on a shopping center roof. The walkways and spaces have been properly planned, and each and every solar panel can easily be accessed. Sometimes walkways are also installed. This is done to protect the roof from damage from walking. There are 2 types, either metal, like these ones, or fiberglass, like these ones. It does look good and protects the roof, but but it also adds lots of extra cost and installation time and labor. So it's only really required in very dusty areas where a lot of cleaning is required. Lastly, I'm happy to share with you links to a few national and international mounting system manufacturers. Please keep in mind that you can reach out to us via email and ask any questions that might have been coming up by now. I hope you found this information about mounting systems interesting and useful, and to see you in the next video. Thank you.